The trough that led to the amazing Rosal, Kansas tornadoes on May 18, 2013 was positioned to support another round of severe weather on the 19th. Dew points were reaching into the upper 60s with steep mid-level lapse rates. Mixed layer CAPE levels were heading over 3,000 joules per kilogram. Ample shear was also in place to support supercells. The exit region of an advancing speed max ended up giving further support to strong, widespread convection over eastern Kansas. An outflow boundary was positioned just south of the Oklahoma-Kansas border, and with an advancing dry line, these two would help focus storm initiation and increase tornado potential along that outflow boundary. I chose to stay north in Kansas because I anticipated Oklahoma storms along the boundary would eventually propagate into difficult chase territory, and storms further south along the dry line would enter dense urban areas along the I-35 corridor. Storms ended up erupting in two clumps, one area from east central to south central Kansas, and another pretty much right over the OKC metro area. After observing developing circulation on a high precipitation cell near Oxford, Kansas, storms started to congeal into a severe squall line. This convinced me to advance southward to stay out of that mess and look for opportunities with any storms that might stay isolated on the tail end of the squall line. I eventually caught some decent structure on an isolated supercell near Newkirk, Oklahoma, before migrating eastward and laying hands on some baseball-sized hail near Maple City, Kansas. My first storm of the day is an HP supercell, as seen from 5 miles east of Oxford, Kansas. Looking west, the dark forward flank is pushing up a rugged shelf cloud that almost seems to be a hybrid inflow tail, with the green glow of an approaching rear flank to the left.
Forward flank. Oh, it's really warm right here. I think this is the notch right here. We got RFD coming around the back. RFD shelf back here. That is ominous, man.
After repositioning 3 miles further east, rapid circulation develops at the confluence of the rear and forward flanks. This segment of video is not accelerated. A tornado was reported 6 miles northeast of this location about 6 minutes later. At that point I was already busy racing eastward to stay out of the RFD and developing squall line. I eventually made my way as far south as Newkirk, Oklahoma, and watched an isolated supercell develop at the end of the line. I wasn't convinced that the storm was going to get serious or that the roads to the east would be decent, so I let it go. And it got a tornado warning a few minutes later. After more than an hour rambling around some rocky back roads, I latched onto one last severe warned storm, but couldn't get ahead of it. I did get to sift through its wake and picked up some baseball-sized hail along the roadside.